Hello students, welcome to ALPHORES e-learning classes. So today we will discuss about the capacitors. Okay. So already in the last session just we are given an introduction of capacitors. What is capacitor means? It is a device used to store the charge. Okay. A capacitor is an electric device used to store the charge. We know that what is it? It is a system of two conductors. A system of two conductors of any shape and size. So what is actually the isolated conductor of the capacitor is not applicable. A capacitor nothing but it must consist of two conductors. Okay. So depending upon their geometrical conditions, that is shape and size, the different capacitors can be hold the different amount of charge. Okay, so this is just we are discussed in the last topic about capacitor, and we know the symbols of capacitor. What is the symbol of capacitor is? So this is a symbol of capacitor denoted by C. Okay, fixed capacitance, and this is a capacitance of a capacitor of variable capacitor. This is a variable capacitor. This is fixed capacitor. Okay, and we know that what is charge of the capacitor means. Capacitor is a system of two conductors. Okay, one of them is given positive, the other is given to the negative. The positive plate of the positive conductor only taken as the charge of the positive conductor is taken as the charge of the capacitor. Okay. Now capacitor is a device, okay, which is used to store the charge, and we know that the different capacitor can hold the different amount of charge. Now what is capacitance? Capacitance of a capacitor. Capacitance. See, capacitance is a physical quantity. Okay. See here. For example, we know what we are saying actually. If two conductors, one of them is given to the positive charge, the other is given to the negative charge. Okay. The charge of the capacitor is nothing but charge of the positive conductor. What is capacitance means actually? The charge of the capacitance if gradually increasing, the charge of the condensers, that means charge of the positive conductor is gradually increasing, then the potential difference across the two conductors also increases. What is VB? The potential difference between the two conductors. We know that what is capacitor consists of two conductors. Okay, VB the potential difference across the conductor, QB the amount of charge. Whenever we are increasing the charge of the capacitor, the potential difference between the plates of the capacitor is also increases. Q proportional to V, we may write here Q is equal to CV. What is Q is equals to CV? Here the proportionality constant C is called as capacitance. Capacitance of the capacitor. Capacitance of the capacitor or the conductor. Okay. This capacitance does not depends upon the charge and potential. Capacitance depends upon first one, geometry of the conductors. Geometry of the conductors. That is shape and size of the conductors, and distance between the conductors. Distance between the conductors, and medium between the conductors. Okay. See, what is C be the constant value? The charge of the capacitor is directly proportional to potential difference. Q proportional to V, here we may write Q is equals to CV. The proportionality constant C only called as capacitance. Okay. From this equation we may write like this. Capacitance C is equals to Q by V. What is capacitance? C is equals to Q by V. Means the ratio of the charge of the capacitor to its potential. The ratio of charge of the capacitor to its potential is potential difference between the conductors is called capacitance. See, it is a scalar quantity. Capacitance is a scalar. What are the units? The SI units we may write like this. SI units are charge coulomb per volt. Coulomb per volt. Or we may write like this. Coulomb per volt, or this is Farad. Scientist name denoted by capital F. That is 1 Farad can be numerically equals to 1 coulomb of charge by 1 volt. 1 coulomb per 1 volt is equals to 1 Farad. Okay. The SI units of capacitance is coulomb per volt, or in other words, the other units we may write Farad denoted by capital F. Okay. To maintain the potential difference here 1 volts, we are supplying the charge to the two conductors is 1 coulomb. 1 coulomb of charge is given to the plates of the capacitor. Then the potential difference between them is 1 volts. Then we may say that the capacitance of that capacitor is 1 Farad. 1 Farad is equals to 1 coulomb per 1 volt. Actually, what is here? Farad is a huge quantity. Farad is a very huge big quantity. So that here we are using submultiples. Farad is a huge value. Farad is huge quantity. So that we are using submultiples of Farad. Submultiples. Farad, like millifarad. Millifarad means 10 power minus 3 Farad. Microfarad, 10 power minus 6 Farad. Nanofarad, 10 power minus 9 Farad. Picofarad, 10 power minus 12 Farad. Okay. Okay. Capacitance units is Farad only, but Farad is a very huge quantity. So we cannot get the capacitor of 1 Farad in general. Okay. It is very huge quantity, so that we are using what is submultiples like millifarad, microfarad, nanofarad, picofarad, submultiples of Farad. You may take any capacitor, these are in the submultiples of Farads. Okay. So what is capacitor? Is a device used to store the charge. But what is a capacitance? Is a it is a physical quantity, can be defined as the ratio of the charge of the capacitor to its potential difference between the two conductors is called as a capacitance. The SI units of capacitance is Farad, okay, which can be denoted as 1 Farad is equals to 1 coulomb per volt. But Farad is a very huge quantity, so that we are using submultiples of Farad like millifarad, okay, microfarad, nanofarad and picofarad. Now what is a capacitance of a spherical conductor? For example, you may take a capacitor with spherical in nature, isolated sphere. See, capacitance of the spherical capacitor. Okay, here we are taking a sphere, conducting sphere of radius r, capital R. the charge is given, a positive charge is given, plus Q. The spherical condenser is charged to a potential V. Only this is here only a spherical conducting sphere of radius capital R is taken, and the second conductor is here considered as earth. Earth will be considered as the second conductor of the spherical conductor. Okay, actually what is capacitor? We are saying it is a system of two conductors. In case of spherical capacitor, here we are saying a sphere, a conducting sphere of radius R will be taken as a first conductor. The second conductor is treated as earth only, second conductor here. Thus here the spherical conductor is charged to up to a potential V. Okay, what is the charge given to the sphere is Q. Then we may write potential difference. What is always the potential of the earth will be taken as 0. Potential of the earth is always, it will be 0 because it consists of so many number of charged particles. Electrically, what is earth is neutral. If you are adding some charged particles to the earth, or if you are removing some charged particles from the earth, the potential of the earth cannot alter. It is always taken as 0. Potential of the earth is always 0. Now what is the potential of the sphere on the surface is? Potential V is equals to, here we may write potential V is equals to 1 by 4 pi epsilon naught, okay, Q by R. Okay, this is a potential of the sphere. V is equal to 1 by 4 pi epsilon naught Q by R. But we need to find the capacitance. What is capacitance? Capacitance C is equals to, we know that C is equals to Q by V. What is the capacitance? C is equals to Q by V. Now what is Q be the charge of the capacitor? Here also Q only. But what is V? V is equals to Q by 4 pi epsilon naught R. Now Q get cancelled. Therefore what is C is equal to, here we got 4 pi epsilon naught R. Means if you are observing this capacitor, the capacitance of the spherical capacitor, what is C is equals to 4 pi epsilon naught R. C is equals to 4 pi epsilon naught R. Means the capacitance of the spherical capacitor does not depends upon its charge, isn't it? Here there is no Q here. The capacitance of the spherical capacitor does not depends upon its charge, okay, but it depends upon the size of the radius of the sphere, radius of the spherical conductor, and also the capacitance of the spherical capacitor also depends upon at which it is placed, at which it was placed. Okay, means epsilon naught is there. What is epsilon naught? It is a permittivity of free space. Okay, at what place the spherical capacitor we are placing, it depends upon the place at which it is placed, and it depends upon the size of the spherical condenser, that means radius. For a given place, okay, if epsilon naught is also constant, we may write C proportional to R. C is proportional to R. Capacitance of the capacitor does not depends upon its charge and does not depends upon its potential. It depends upon the radius of the spherical conductor, that is a shape of the size of the spherical condenser, and medium between, medium at which it was placed, medium at which it is placed. Okay, epsilon naught, 4 pi is a constant. This is about the spherical capacitor. Okay, for suppose if they given a problem, may be asked, two capacitors are charged, okay, in the ratio of some 3:4. Two spherical capacitors are charged in the ratio of Q1 is to Q2 is in the ratio of, okay, 3:4. 3:4. Okay, then charged in the ratio of 3:4, Okay, they reaches the same potential value. V is constant here, V constant. Then what is the ratio of their capacitors? We know that what is C is equals to Q by V. V is constant, so we may write what is C proportional to Q, that is C1 is to C2 is also 3 is to 4. Instead of Q1, Q2, if they given like this, if two spherical conductors having the radii in the ratio 3 is to 4, radii in the ratio 3 is to 4, okay, they charge it to the same potential. Okay, what is the ratio of the capacitors means, again what is C is equal to, we may write like this, C is equals to 4 pi epsilon naught R. Here we may write C proportional to R. C1 is to C2 is equals to 3 is to 4. Okay, what is C? You should remember these formula. The capacitance of the spherical capacitor C is equal to 4 pi epsilon naught R. In the same way, we know that what is earth is also in the spherical in nature. If we calculate the capacitance of the earth, okay, capacitance of earth, see here, what is the earth will be in spherical in nature. Earth is spherical in nature. The radius of the earth is 6,400 kilometers. What is the radius of the earth is 6,400 kilometers. It will be the radius of the earth. Can be written as 64 kilometers. Okay, 1 kilometer means you should convert into meters. 6,400 kilometers, 6,400 kilometers. Now into 10 cube. Here 10 square is a 10 to the power of 5 meters. 64 into 10 power 5 meters. Okay. So radius of the earth is 64 kilometers, 6,400 kilometers, that is 64 into 10 to the power of 5 meters. What is capacitance? C is equal to 4 pi epsilon naught R. And we know that 1 by 4 pi epsilon naught 9 into 10 power 9. Then 4 pi epsilon naught is 1 by 9 into 10 power 9. And what is value? 64 into 10 to the power of 5. 64 into 10 to the power of 9. So 64 by 9 into 10 power 5 minus 9, it becomes minus 4. Okay. Now 9 sevens approximately, this is, you will get 7.11 into 10 power minus 4, or which can be written as C is equals to 711 into 10 power minus 6 farad. 711 into 10 power minus 6 farad, which can be written as 711 microfarad. Okay, approximately what is the capacitance of the earth is 711 microfarad. Okay, because we know that the earth is in spherical in nature, and we know that what is the radius of the earth is 6,400 kilometers. Already studied in the first year gravitation topic. So 64 into 10 power minus 5 meters. 4 pi epsilon naught value is 1 by 9 into 10 power 9. Okay, or 6,400 kilometers, convert into meters, 64 into 10 power 5. 64 by 9. So 9 sevens are 63. Here you will get 7.11 into 10 power minus 4. Can be written as 711 into 10 power minus 6. That is 711 microfarad will be the capacitance of the earth. Okay. One is principle of the capacitor. Principle of capacitor. So we know that what is capacitor is a system of two conductors. The capacitance of a capacitor depends upon the geometry, that is shape and size, but not on the charge and potential. See, for suppose to increase the capacitance of a capacitor, so what is the general method? By changing the dimensions. We know that capacitor is a device used to store the charge. Same as like some container, different containers can hold the different volume of the liquid. To increase the quantity of the liquid, we should take the size of the liquid also, size of the container must be increases. In the same way, now to increase the charge, the amount of charge must be increases. The amount of charge held by the capacitor should be increases by increasing the size of the capacitor. This is a general process. Okay, capacitor can hold the charge. It depends upon its geometry of the conductors, that is shape and size. By changing the shape and size of the conductor, what happens? The capacitance may be increases. By increasing the size, the capacitance also increases. By decreasing the size, the capacitance decreases. But this is a general method, first method. Now here, without increasing the size of the capacitor also, we can increase the amount of charge. That is the principle involved in the capacitor. See, for example, here you should take a conductor, okay, A given a positive charge. A conductor A given a positive charge here. The charge resides on the surface here. This is a conductor A. Only one single conductor here we are taken, which is given a positive charge. A be the conductor. But what is capacitor? It consists of two conductors. Now, this is a conductor A, here we are taken. Given a positive charge. At this conductor A, here we brought an uncharged conductor parallel to the A, an uncharged neutral. An uncharged conductor B brought closer to the A. Uncharged means neutral. An uncharged conductor B is brought closer to the conductor A. See, the near side of the B, an opposite charge is induces by the conduction process. Here the negative charge will be induces. The inner side of the conductor B, negative charge induces. And the outer surface of the B, again positive charge is induces. Okay, actually what is here, we are taken only the conductor A only. This is a conductor A given a positive charge which resides on the surface. Okay, later on we brought a neutral conductor, uncharged conductor, okay, bringing closer to the conductor, positive conductor A, so that what is a negative charge is induces in inner side of the conductor B to nullify that a positive charge is induces outer side of the conductor B. See, actually what is we know that the potential of the earth will be taken as 0, and always positive charge is at high potential, negative charge will be at the low potential. See, whenever we brought these conductor B closer to the A, due to these negative charge of the conductor B, the potential of the earth will be decreases. Due to the induced negative charge of the conductor B, the potential of A will be decreases, because this is a low potential, this is a high potential. If there is no negative charge, what happens? The potential value remains constant here. But due to these negative charge, what happens here? The potential of the A will be decreases. And the same time simultaneously, again positive charge is there here. Due to the positive charge, again the potential of A will be increases. Due to the induced negative charge, potential of A will be decreases. Due to the induced positive charge on the outer side of the conductor B, potential will be increases. But the effect is the negative charge is closer to the conductor A as compared to the positive charge. What is the negative charge is closer. So due to the negative, potential decreasing, due to the positive, potential of A is increasing. but the effect of negative charge is more on the conductor A because it is closer. Okay, because the negative charge is closer to the conductor A. So finally, what is the resultant? The potential will be decreases. Potential of A will be decreases. Okay, see here. Then later on, we should connect. Now this is again positive charge. Now what happens? This is a conductor A, this is a conductor B. Due to the negative charge, potential of A will be decreasing. Due to the positive charge, potential of A is increasing. But negative charge is closer. The effect of the negative charge is more than the positive charge because it is closer to the conductor A. And then after these conductor B, the outer side of the conductor B will be earthed. Okay, what is outer side of the conductor B is earthing. When it is earthed, what happens? The positive charges of the outer side of the B will be nullified, neutralized. Okay, this is a positive charge. The electrons flows from earth to the conductor B and they neutralize. Outer side of the B will be neutralized. Okay, then what is finally? Only negative charge is there inside the conductor. So then what happens? Negative charge is decreasing the potential, positive charge is increasing the potential of the conductor A. But whenever we are connecting these outer surface of the B to the earth, the positive charge is neutralized. Only the negative charge is there. That means the potential of A will be decreases. Potential of A is decreases. We know that actually what is Q proportional to V? Means whenever we are given a isolated positive charge, here positive charge to the conductor A, V be the potential. V be the potential. When only single conductor is present, V be the potential. At the potential of V, the capacitor can hold the maximum charge Q. At the potential of V, what is the capacitor can hold the maximum charge V? Maximum charge is Q. But now what happens? The potential of A is no more V here. The potential of A is decreases by, okay, decreases. It is less than V. Now to reach the potential value up to the V, we can give the charge. Means we can supply the charge to the capacitor. See here, without changing the dimensions, we are not changing the shape and size of the condensers. Just we are connecting a neutral conductor, an uncharged conductor brought closer to the given positive conductor A, and the outer surface of the neutral conductor is earthed, so that the charge of the capacitor, the amount of charge held by the capacitor is increasing. This is a principle of the capacitor. Okay, in general, by increasing the size, we can increase the amount of charge held by the capacitor. But here, without changing the dimensions, by lowering the potential. How we are lowering the potential? An uncharged conductor brought closer to the conductor and which is earthed, so the potential value decreases. To reach the potential value up to the point V, we can supply the charge. So now the charge no more Q, it is increases. So this is a principle of capacitor. Okay.